To my chemistry class once again. This is Teacher Atarhe. In today's class, we're going to discuss ionic reaction and equation. In our previous lesson, we treated salt, types of salt, and so on and so forth. So in this regard, we said compounds such as acid, alkali, salt, and triacylcarbonate 4 that dissolves in water tend to be in solution in form of ions. So these ions, they move around the system in a constant motion. So this ion can be positive or negative. So in this now, most of this reaction, this compound undergo when they react with between two of them, individual particles, individual ions interact with other ions to form what is known as chemical reaction. So in this aspect, so since this reaction involves ions, there is a high tendency for a student to know how to write this equation involving these compounds. So we said when these compounds, when they react, these individual ions tend to interact or collide with each other. So we said a compound contains two parts. It contains the positive side and the negative side. And most times the positive side comes first. So we're going to use a very simple illustration. So when we have neutralization reaction that involve ACl reacting with sodium hydroxide, aqueous, to give salt, water plus water main liquid. So there is an arbitrary rules that govern how to write this equation in ionic form. So in this aspect, there are simple rules that we follow. We said one of them, we said do not break down or do not break up any solid, gaseous or weakly ionized substances such as water, weak acid, and base. So that is to say, in a given equation, we said the state at which such compound exists determine how these compounds can dissociate. So when they dissociate, it breaks down into two parts. It breaks down into the positive side and the negative side. So with the next law we're going to talk about how to write this ionic reaction or equation is that we cancel out. The next step is to cancel out like ions on both sides. That is at the reactant side and at the product side. We said the third criteria is that to balance the atom and charges on both sides of the reaction, must be balanced. Okay, following these arbitrary rules, we should be able to write this equation in ionic form. Since they exist in ionic form, we're going to write each of them. So we said do not break up any solid, gaseous, or weak ionized substances such as water, weak acid, and base, but we must represent them as a molecule in the equation. So we said too, we cancel out like ions on both sides, which is the reactant and that of the product. We say the atoms and the charges on both sides of the reaction must be balanced. That is, let's use a very good this above equation. Having known the criteria for us to write ionic equation, let's know about it. So we said a given reaction, this is a compound, this is a compound, this is a compound, this is a compound. But the state of this reaction, this is an aqueous state, this is an aqueous state, this is an aqueous state, this is what? In liquid state. We say this water that is a weak ionized substances. We do not break them into two parts. So this one, how let's represent this compound in form of ionic form. We say the first one comes as a positive, this comes as a negative, this will come as a metal positive, the OH will come as negative. We're going to have sodium plus Cl aqueous. This is aqueous, this is aqueous, plus H2O liquid. So in this aspect, Since we did not break this H2O, we represent them as I've said from the arbitrary rules that we represent them as a molecule. So what is there now? We said the next step is to cancel like terms on both sides. If you should see here, we have the sodium ion is here, the sodium ion is found here. We're going to have the Cl ion, you have the chloride ion here. So what is left here, you're going to have H2 plus OH negative aqueous to give water molecule. So in this one, this process at which we write this chemical reaction is known as ionic equation. So if you are asked to write the ionic equation of a given reaction, there's a high tendency for you to know these arbitrary rules that guides this writing of ionic reactions. So in this aspect, we said we must break down this compound. We say when this compound, when it dissolves in water, they give what is known as free particles. According to Arrhenius equation, they give moving particles within the system, and these particles, they are known as ions. These ions can be positive or negative. So in this aspect, each compound contains two parts. It contains the positive and the negative. So each of them are going to break them into two. So how can we know the number of ions that are present in each of these ions? Is that each of them, we can use the valency of each of them to represent them. So each of them have, like this one I have only one valency, this one have one valency, this one have valency, one valency, this one have one valency. So we can use the number of valency to represent them. So hydrogen that have only one valency, to use the positive as a metal, we'll just use this as a, in this regard, as a cation. So what we do here is that these ions, when you break them, when you dissociate, when they dissolve in water, according to Arrhenius, they give what is known as moving particles. These particles, they are known as what? Ions, as I've said. So when they break down, you're going to have the positive and the negative, the positive and the negative. So the next step is for you to cancel out whatever that is what that is present at both sides, so that you have the final equation is hydrogen ion reacting with OH ion to give water molecule. So in this aspect, let's use a very good example as well. We are going to use let's use reaction between calcium hydroxide reacting with sodium nitrate. Here we are going to have calcium 2 plus water. So this one is aqueous, this one is aqueous as well, this is aqueous. So in this aspect, we are going to write out this ions. So the first step in this aspect, you must balance this equation. For us to balance this equation, it's very, very important for you to balance this equation. We have one calcium here at the reactant side. We have one calcium here. We have 2 oxygen here. We have 3 oxygen here. We have 3 oxygen here times 2 here. We have 6 plus here is 7. So let's balance this equation for us to have a proper ionic equation. Let's have calcium is 1 here. We have oxygen, we have hydrogen, we have nitrogen. These are the 3 elements that form this reactant part. So whatever that is found here is always found here. We're going to have calcium as well, oxygen, hydrogen, and nitrogen. So by so doing, let's have a simple one. On this side, we have the sodium. Calcium is 1 here. Oxygen is 1 here times 2. We're going to have 2 plus 3 here. We have 5. Here we have oxygen is 3 here times 2 is 6. 6 plus 1 here we have 7. Here we have hydrogen 1 here times 2. You're going to have 2 plus this is 3. 3 hydrogen here. We have hydrogen is 2 here. Here we have nitrogen. Nitrogen is how many here? We have 1. Nitrogen is 2 here, because these 2 is affecting everything that is found here. So what is happening here? How can we balance this equation? Since we have only one n here, we have n here, we have n here. Let's make this n to be 2. Let's balance this n first. N is 2 here. 2 times 1, I'm going to have 2 here. Oxygen is 3 here times 2, 6, plus here is 8. I'm going to have 8 here. So here, what can we do here? Here, let's add 2 here. We should add here 2 times 1 here is 2 oxygen. Oxygen is 2 here plus this We have 6 here, that is 8 oxygen. Oxygen is balanced as well. We have hydrogen is 3 here, 2 here plus 2 here. We have 4 hydrogen. 4 hydrogen. Yeah, how many hydrogen do we have here? We have 2 times 2, 4. Okay, we have 4 hydrogen here. So with this now, we'll say the number of elements present on the reactant side and that of the product, they are the same. We'll say this equation is balanced. So having known this now, let's move to how can we break down this, how can we write the ionic equation of this equation of this reaction. So now we are going to say this compound contain 2 parts. It contains the positive side. Since calcium is a divalent, you're going to write 2 plus. It's a metal. So here you're going to have there's 2 here, 2 times this full compound. You're going to have 2 OH negative. So here you're going to have we are going to have 2 hydrogen ion. Yeah, this 2 is affecting everything I see. You're going to have 2 NO3 negative. You're going to have calcium 2 plus here. You're going to have 2 sodium nitrate plus 2 mole of water, because water is a weak substance. It cannot be represented by what? Dissociation. So we have liquid here as a molecule is represented with a molecule. So now we cancel out whatever ion that are found here that is the same as here. One of them, we say calcium here is here, the same here. Calcium is the same here. We said what is there now. Let's check 2 NO3. We have 2 NO3 here. We're going to cancel this. We cancel this. We are going to talk about what is left here. We're going to have 2 OH negative plus 2 ion to give what is known as 2 mole of water. 2 mole of water. This is aqueous. This is aqueous, and so on and so forth. So this is a simple way at which we can write the ionic equation of this compound. So let's move ahead. Let's talk about other reactions that involve let's use zinc. Let's use zinc. Zinc is solid plus copper sulfate to give zinc sulfate, aqueous plus copper solid. So in this aspect, we say solid substances, we do not break them into 2 because they cannot be dissociated in this reaction. So in this aspect, you're going to have, first of all, we balance this equation. If you can see, this equation is balanced. We have 1 zinc here, we have 1 zinc here, we have 1 copper here, we have 1 copper here. Sulfur is 1 here, oxygen is 4 as well. So in this now, let's break down this compound. I'm going to have zinc. It's a solid. We do not dissociate them, we do not break them up. So we have copper 2 plus SO4 2 minus to give zinc 2 plus SO4 2 negative plus copper solid. Since it's a solid, we do not dissociate them into 2. So in this aspect, we cancel out whatever thing that is found here. We have SO4 2 minus SO4 2 minus here. So we are left with zinc solid plus copper 2 plus to give zinc 2 plus copper solid. So in this aspect, you can see that with the help of these arbitrary rules, writing ionic equation becomes more simple and straightforward. So for a student to understand this concept, one of them is that you must ensure you know this the valency of each of these elements, when they are the number of electrons they are required to give out, the number of electrons that is needed to accept. So in this aspect, you must understand that at this side, you must be very, very careful with the number of electrons you are giving to each part of this reaction. So if you can see this now, we balance this atom. We've said this copper is 2 here. We have this copper to balance the ions on both sides. So if this is your first time of coming to my channel, welcome to my channel. Please, as you watch this video, do well to subscribe to this channel, because new update will be coming up on how to go about chemistry terms and chemistry problem in your examination. Thank you for watching.